Welcome to Chemstorming. As you can see, our today's topic is stoichiometry, mole-to-mole calculation related problems. In the previous video, I introduced stoichiometry and we also listed out the different types of stoichiometric problems, the 4 different types. And mole-to-mole is the first one and it's the simplest one. So let's start with it. So what should we know to do these stoichiometry calculations? The first thing we should know is how to balance the chemical equations. I'll be showing you a small equation and I'll teach you how to balance it. It's very simple. Then we should extract the mole ratio or the molar ratio from the balanced equation. We should know how to find out the molar ratio from the balanced equation. And then we should know a little bit about the dimensional analysis. This is a method which is used to do the calculations related to the similar ratios. I'm going to show you this also. So let's start with a small example. So the question goes like this. Suppose we have 3 moles of nitrogen reacting with sufficient amount of hydrogen. How many moles of ammonia will be produced? So how should we start? The first thing we should do is write the balanced equation. Now I don't see any equations in the question, so how do we write it? We have to find out the equation by reading the question carefully. So if you read the question, it says nitrogen is reacting with hydrogen, which means nitrogen and hydrogen are the reactants. So let's write the reactants first. N2 plus H2. If you read the second part of the question, it says NH3 will be produced, which means NH3 is the product. So let's write NH3 on the product side. Next thing what we can do is, let's write N and H, which are the 2 elements present in this chemical reaction, and let's write the number of nitrogen atoms present on the left side first. So I can see there are 2 nitrogen atoms, and on the right side I can see only 1 nitrogen atom. Next, we'll write the number of hydrogen atoms present on the left side, that's 2, and on the right side we have 3 hydrogen atoms. So to balance the hydrogen atoms, what should we do? We should multiply a 3 on this side and a 2 on this side. So if I multiply 3 with this, I get 6, and I have multiplied 2 with this 3, so I get 6. So here you go, hydrogen is balanced. Now let's check what has happened to the nitrogen atom. On the left side, nitrogen remains 2. But on the right side, as I have multiplied a 2 along with ammonia, NH3, so nitrogen also becomes 2. There you go. So nitrogen is balanced, hydrogen is also balanced. Hence, the equation is balanced. So there you have the balanced equation, which is N2 plus 3H2 giving us 2NH3. So this is our first step. Let's go to the second step. The second step is we have to write the molar ratio from the balanced equation. So first let's write the balanced equation, which is N2 plus 3H2 giving us 2NH3. So this is our balanced equation. Now before we write the molar ratio, we have to identify the coefficients of N2, H2 and NH3. What are coefficients? Coefficients are those numbers that we write just before each compound or element in the balanced equation. So here before N2 we have not written any number, which means we can write 1 over here. So 1 is the coefficient of N2, 3 is the coefficient of H2, and 2 is the coefficient of NH3. So these coefficients actually represent the actual number of moles which are reacting or getting produced. I have explained about this in details in my previous video, so you can just go and check it out. So let's write the molar ratio now. As we already know what is the molar ratio, it's 1 is to 3 is to 2. So this is the molar ratio of N2H2 and NH3. Simple. Next step. Look at the given and the required. So now is the important part. What do we need to do? We have to read the question carefully and find out what is given and what is required. What do we need to find out? So given is 3 moles of N2 and required is the moles of NH3. And because hydrogen is present in sufficient amount, so we don't need to worry about hydrogen moles. So we are just going to look at the moles of N2 and moles of NH3. So now we will simply write the molar ratio between N2 and NH3. N2 and NH3, the molar ratio is going to be 1 is to 2. So this is the molar ratio. Then we are going to use this molar ratio to find out the required number of moles. Here we are going to use the dimensional analysis. So dimensional analysis basically uses the unit to do the calculations. So first we'll write the given. Given is 3 moles of N2. 3 moles of N2. So here the unit is moles of N2. So I have to set up the ratio in such a way that the moles of N2 will get cancelled. So what I can do is I can just simply multiply and do a division sign, and I should write the moles of N2 at the bottom so that here and here it can get cancelled. So which moles I'm going to use? I'm going to use this 1 mole from the molar ratio for N2. So I have 1 mole of N2 here. And then on the top, I'm going to use this 2 moles of NH3 from the molar ratio. Now let's see how the units are getting cancelled. We have moles of N2 here and moles of N2 here. So I can simply cancel it. Then what is remaining? 3 multiplied by 2 moles of NH3 divided by 1, which means we are left with 6 moles of NH3. And that's our answer. So as per the question, when 3 moles of nitrogen reacts with sufficient amount of hydrogen, then 6 moles of ammonia will be produced. So that's how we are going to solve these kind of questions. So we have basically used 4 steps. So let's summarize the steps and then we will do another example. So let's look at the steps. Step 1 is to write the balanced equation. Step 2 is to write the molar ratio. Step 3, we look at the given and try to find out what is required. And step 4, we use the molar ratio and the dimensional analysis method to find out the moles of the required compound. Now, as you are clear with the 4 steps that we are going to follow, let's solve another example. Example 2, we want to produce 8 moles of ammonia. How many moles of nitrogen would be required? So our first step is to write the balanced equation. So let's write it. N2 plus 3H2 giving us 2NH3. We already have the balanced equation from the previous question. Then step 2, write the molar ratio. 1:3:2. So this is our molar ratio. Then we look at the question and find out which is given and which is required. So I can see 8 moles of ammonia is given and moles of nitrogen we have to find out. So we are going to concentrate on ammonia and nitrogen. So what's the molar ratio of ammonia and nitrogen? N2:NH3 is nothing but 1:2. The same molar ratio. Then we are going to set up the dimensional analysis using the given moles. So I have 8 moles of NH3. So I'll write 8 moles NH3 here. Then I give a multiplication sign and then I have to write the moles of NH3 at the bottom from the molar ratio, which is 2 moles. Why I write it here? Because I can cancel the moles of NH3. And then on top, I'm going to write the moles of nitrogen from the molar ratio, which is 1 mole. So I want to get rid of the moles of NH3 so that only moles of nitrogen will be remaining, which is our required. So I cancel the unit and then I'm left with 8 multiplied by 1 divided by 2, which is nothing but 4. And the unit which is remaining is moles of N2. So this is our final answer. So as per the question, if you want to produce 8 moles of NH3, then you have to take 4 moles of nitrogen. So this is how you are going to follow the 4 steps to solve these kind of mole to mole stoichiometric problems. Let's quickly summarize this video. We basically learned how to solve mole to mole stoichiometry problems. We did 2 examples and we found out that these are the 4 important steps that we need to use to solve these questions. Writing the balanced equation, writing the molar ratio, then looking up for the given and the required, and then using molar ratio and dimensional analysis to find out the answer. I hope these steps are clear to you and you feel a little more confident to work out these kind of problems by yourself. Thank you so much for watching this video. If you have any doubts, you can comment in the comment box and I'll make sure that I clarify your doubts by replying you. Happy learning chemistry and don't forget to subscribe and like and share my videos if you really enjoyed it. Thank you.